Okay, let's take a look at this question. Question 6a, part 1. Find the exact values of sine 15 degrees and 75 degrees. Let's just work with the first question first, 15 degrees. Straight away, when I see 15 degrees, I know, it's very close to a certain angles that I like. 30 degrees, 60 degrees, 45 degrees. Okay, I should write it in order. 30, 45, 60 degrees, and the regular angles, 90, 180, 270, 360, right? And 0 degrees as well. Very easy to deal with numbers. Because why do I like them? Because they have exact values. Notice that 15 degrees is very, very close to 30 degrees already, right? It's just exactly half of the angle. Or you could say that 30 degrees is double of 15 degrees. And oh yes, this is a mistake here. Sine of 30 degrees is actually 1/2, right? It's 1/2. You can just draw the triangle. Here's 60, here's 30, here's 2, here's 1, here's 2 square minus 1 square, which is 4 minus 1, which is 3. Then you can work it out. What is your sine of 30 degrees? Opposite over hypotenuse. It's a half. Okay, this is half of a, what do you call this? An equilateral triangle, right? Half of an equilateral triangle. Anyways, so sine of 30 degrees I know is half. So that's useful. But more than that, I also know that cosine of 30 degrees, and by complementary identities, it's the same, right? As long as these two angles add up, or sum is equal 90 degrees, then you will be equal, cosine and sine. They're called complementary identities. So cosine 30 degrees equals sine 60 degrees, which I know is just root 3 over 2. Okay? Can. So now, how could I convert my sine of 30 degrees, which I know is half, into a sine of 15 degrees? Well, we know that there's double angle formulas. So let's say that we looked at this first guy. What would happen if we looked at this first guy? There will be a problem. Why? Because the double angle here, 2a, has to be 30 degrees, which means that our 1a would be what? Half of 30, so 30 degrees. So if 2a is 30 degrees, 1a will be 15 degrees. So let me just illustrate this. It won't work. I'm telling you there's a problem. Bad idea. If you try sine of 30 degrees equals to sine of 2 times 15 degrees, what you'll get is 2 sine 15 degrees cosine 15 degrees. You see sine 15 degrees, then you're happy. Yay, that's what the question wanted. So maybe I can solve for sine 15 degrees, right? And sine 30 degrees, I know that's half, so it's just half. Right? Wow, you think very good, very good. You can solve for sine 15 degrees. However, there's a problem. Problem being cosine 75 degrees. Oh no, you cannot find the value of cosine 15 degrees. Why? Because there's no why. It's just because we didn't teach you how to find it out exactly. You only know how to find the exact values of the Trigo ratios where the angle is 30, 45, 60, or maybe the 90 degree multiples, 0 degrees, 90 degrees, 180, 270, 360. They're all, and how to find the corresponding value by looking at the sine curve or cosine curve, right? Those are the only trig ratios that you know the exact values of. In this case, 15 degrees cosine, you don't know yet. So you cannot use this identity. It's a bad idea. So what should you use next? Look at my arrow. You should be looking at the cosine 2a identities. Cosine 2a identities, I wrote down all three for you already. You can refer to your formula list. Now, which one could I use that is related to sine 15 degrees? You remember you want to relate to sine. This one or this one, right? Definitely not the last guy. There's a cosine square. That's not helpful. It's either this guy or that guy. Cosine square minus sine square, or 1 minus 2 sine square. Which one would I pick? Let's say I picked cosine square minus sine square. Again, there will be a problem. Do you see the problem? Let's say you have cosine of 2a being 30 degrees. Okay, then you half the 30 degrees, so you get cosine square of 15 minus sine square of 15 degrees. I'm lazy, that's why I never read out the degrees, but you should know. In this case, cosine 30 degrees, good. I know the value. It is simply root 3 over 2. Cosine 15 degrees, then you square it. Oh no, that's a problem. Minus sine square 15. Great, that's what I want. I want this. I don't know this. I don't know this. So that's a problem, huh? Huh? You cannot use it because again there is a cosine 15 degrees. So that's another bad idea. That's another bad idea. Bad idea number 2. Bad box. The bad box. Huh? So of course now that you have realized this one doesn't work, this one doesn't work, then by elimination you're only left with this guy lah, huh? Yeah. So you're only left with cosine 2a equals 1 minus 2 sine square a. That seems promising. Let's try that instead, huh? So we want that double angle, the 2a, to be 30 degrees. So cosine of 30 degrees is equals to what? 1 minus 2 sine square single a. 1 minus 2 sine square single a is half of 30 degrees, so 15 degrees. Oh, that seems promising. Yes, and yes it is. Cosine 30 degrees we know is root 3 over 2. Root 3 over 2. Okay, good. And 1 minus 2 sine square of 15 degrees, well, we can't do much with it. Let's try and make, okay, if you don't understand what this means, one clever substitution you can make, I don't recommend, I'm not sure, but I would actually think that for the start, if you still don't understand this, maybe it will be helpful if you replace the sine of 15 degrees, sine square, you rewrite it as sine of 15 degrees as a x, you replace the sine of 15 degrees as a x, then you rewrite it as a x squared. In other words, you write down root 3 over 2 equals to 1 minus 2 capital X squared, where capital X is sine of 15 degrees. Then maybe it's easier for you to see. Now I want to make sine of 15 degrees, which is the answer I want, as the subject. What would I do? How do I do that? Make x a subject, just very simple. Maybe I'll bring this term over so I can make it positive. Then I'll bring the root 3 over 2 over as well. So 1 minus root 3 over 2. Okay, then I can solve for x squared, just divide by 2. So half minus root 3 over 4. Do you know how I did that? I just simply multiplied by half on both sides. Yeah, and then distribute the half into each of the terms, right? There's a there's a pair of imaginary brackets. Half times 1, half. Half times negative root 3 over 2, root 3 over 4. Okay, can. Then you get x squared equal to this guy. X squared equal to this guy, which means that now maybe it will be better if I combine the fraction. There's a 1 over 2, so it's the same as 2 over 4, so I can rewrite as 2 minus root 3 over 4. X squared equals to that. But wait, what's x squared? It's nothing but sine square 15. Sine square 15 degrees. Sine square 15 degrees, I already know what is that. That's our answer squared. So we need to take the square root. Take the square root in order to find our answer. So how do we do that when we what do we have to do when we take the square root? You know, right? You just of course, so to go from x squared into x, you just take square root. Then that's what you do. You just take copy and paste the right hand side, but you draw in this square root symbol. Okay, but you also have to include a plus minus sign in front. Don't forget the plus minus sign. And at the beginning, I think I wrote this down without explaining. Sine of 15 degrees, it has to be positive. Why? Because ASTC, add sugar to coffee, all science teachers crazy. In this case, 15 degrees is in which quadrant? Quadrant 1. Quadrant 1 is A. A means what? All the angles are positive. So all the trigo ratios will be positive. Sine of an angle in quadrant 1, definitely positive because of A. Even if it's in quadrant 2, it will still be positive, like sine of 135 degrees, for example. But in this case, we have sine of 15 degrees is positive, so let's go back to what we have found so far. Oh, we managed to find that there's a positive and a negative root because we are trying to take square root, right? That's a standard rule. But because we also know that sine 15 degrees, because sine 15 degrees is positive, 15 degrees is in Q1. Therefore, sine of 15 degrees is equal to positive square root of 2 minus root 3 over 4. Whole thing take the square root. Positive root. Done. But that's not all for this question. We also need to find out what is the next part. Sine of 75 degrees. Sine of 75 degrees. Sine of 75 degrees. That's a bit difficult, but actually not really. Let's just see 75 degrees. 75 degrees. Do you notice that it's really just almost how do I phrase this? It's almost the same as a standard angle 60 degrees. Well, of course it's not equal. You still need to add a 15 degrees, right? Okay, fine. But let's say, okay, so what does this mean? It means that we can break down our 75 degrees into a sum, which means that we could take cosine of 75 degrees and cosine of 60. Sorry, not cosine, sine, right? We wanted sine. Yes, let me just move this a bit over. Sine of 60 degrees, sine of 75 degrees. But wait, sine 60 plus 15, sine A plus B. I know a formula for that. Sine A cos B plus cos B, sine A cos B plus cos A sine B. Sorry, should be cos A, then sine B. Very good. And then you see, sine 60, I know what's this, square root 3 over 2. Cosine 60, I also know what is this, it is half. Sine 15 degrees, I also know what is this, I just found out just now, square root, huge square root minus 2 square root 3 over 4. But then there's this problem over here, cosine 15 degrees, what is cosine 15 degrees? I don't know. No need to worry, actually there is a way to find out what is cosine of 15 degrees, so we have created an extra problem for ourselves, but I think it's still manageable. Cosine 15 degrees, where did you see it before? Where did you see it before? In our back box, right? In our back box. Oh, cosine 15 is here. Oh, cosine 15 is here. Which one is simpler? Which one is simpler if you want to solve for cosine 15? Definitely the one with less smaller power, right? This one power 2, wow, so difficult. Square, later you need to square root, right? To get back the original, which means that we have to plus minus. So no go. This one don't want. We want this one instead. Half equals 2 sine 15 degrees cosine 15 degrees. Let me just copy and paste this over here. From the fact that what was it? Sine of 30 degrees is equals to 2 sine 15 degrees cosine 15 degrees. But wait, can we make cosine 15 degrees a subject? Yes. And also because it's useful because we already know what sine of 15 degrees. So now the only unknown left is cosine of 15. So cosine of 15 degrees is really just half divided by 2. Okay, wait. You know what? Before I do that, I think it's easier if I just substitute the sine of 15 degrees. So half is equals to 2 times sine of 15 degrees, which is this huge square root. And inside the square root, we have 2 minus square root 3 over 4. 2 minus square root 3 over 4. Multiplied by a cosine of 15 degrees. Can we make cosine 15 degrees a subject now? Yes, we can. Cosine of 15 degrees. We just work with numbers, it's easier to visualize. This 2 we bring over, so it becomes 1 over 2 times 2. The original half, but you introduce the extra 2, we bring the 2 over. But you also have to introduce the fraction. Introduce the sine 15 degrees. So this guy is now cosine 15 degrees. Let me try and simplify. 1 over 4 times square root of this guy. Honestly, at this stage, I think it is okay. It is okay to leave this as a square root within a square root, like a square root 3 inside a square root, and a square root on a denominator. Oh no, it's not a rational denominator. But it's okay. I think at this stage, it's still fine to leave it alone. So now that we have obtained our cosine 15 degrees, what we can do is we can substitute it back in. This question mark is no longer a question mark. We know what it is, so we can just substitute it in. Just to be same style, we keep it pink color. Okay, we got the value. Then now we just need to simplify a little bit about this with this expression. root 3 over 2 times 1 over 4 times that. 4 times square root of 2 minus root 3 over square root of 4. Square root of 4 is really just 2, so it means that we will have 4 cancelling with the 2, which means you're left with a 2 here. So overall this first term will just simplify into, okay, this first term that I'm referring to will simplify into root 3 over this 2 times this 2, 4, multiplied by this guy. Okay, I'm sorry for using the same color. Let me try using a highlighter instead. Okay, I mean this 2 multiplied by this 2 multiplied by this numerator. Oh, sorry, this how do I phrase this? The numerator of the nested fraction, which is now part of the denominator. So 2 times 2 times square root of whatever. 2 times 2 is 4 times the square root of whatever, 2 minus root 3. Okay? So that's your first term. Good. How about your second term? It is plus half multiplied by square root of whatever. Okay, we can simplify the square root a bit. So square root 2 minus square root 3. Then square root of 4. But wait, square root of 4, I know that is just 2. 2 times 2 is 4. So plus 1 over 4 times 2 square root of 2 minus root 3. Like this. And then we are done.